Okay, welcome back. This is part 2. So if you're on part 2, that means you were amazing and you watched the first video. So this video, I'm finishing up with the factorial ANOVA. So this is the ANOVA table for factorial for a two-way design. So columns would be factor 1, rows would be factor 2, and then our interaction is our new F. So how do we get there? Well, this is, again, a glorified version of your one-way ANOVA table. We're going to work through those same formulas we had before. If you remember, for calculating degrees of freedom, you had a couple of options. Your number of conditions minus 1 or k minus 1. So number of rows would be how many conditions, levels, treatments, groups did I have for factor 1. Columns, again, this could be factor 2. How many conditions did I have for levels, conditions, groups, treatments for factor 2. And then my interaction, you've got two different formulas. One is your total number of cells. So in the case of a 2 by 2, I have 4 cells. In the case of a 3 by 3, I have 9 cells, minus my degrees of freedom for my first factor, minus the degrees of freedom for my second factor at minus 1. That's kind of a lot. I'll give you another trick. Just do your number of rows times your number of columns, hence the term interaction. So that's a fun, easy one. Degrees of freedom within is going to be the same thing. Degrees of freedom, total number of people in group 1 minus 1, total number of people in group 2 minus 1, etc. And so that is based on your conditions. So in a 2 by 2 factorial design, that's between, if I had 10 people in each condition, I would have 9 plus 9 plus 9 plus 9, or 40 minus 4, my total n, total number of people, minus my total number of conditions. And then again, your big total degrees of freedom is n minus 1. Then for figuring out your mean squared variance, it's always sum of squares over degrees of freedom. That's what it is for everything. And then your F is variance between over variance within, or variance over error. All right, so let's go back to this table. Sum of squares divided by degrees of freedom equals variance. For factor 1, sum of squares over degrees of freedom, variance for factor 2, sum of squares over degrees of freedom, variance for my interaction, sum of squares over degrees of freedom, variance for my within, variance between, variance within, my F. Variance between, variance within, my F. Variance between, variance within, my F. So I tried to color code that to make it simpler. So let's go ahead and take a look at this with that doctor data. So this is made up data. This doesn't connect directly to the NPR study. It's just to give us an example of working through these. So it was a 3 by 3 design. 3 minus 1 is 2. 3 minus 1 is 2. 2 times 2 is 4, and that's our interaction. Our within would have been going through and subtracting how many people were in each of those 6 conditions and then adding those up. Okay, so 18 divided by 2 is 9. 20 divided by 2 is 10. 80 divided by 4 is 20, 110 divided by 55 is 2. So to get my F for dose, is there a main effective dose? I would have done 9 divided by 2 and got 4.5. Is there a main effective modality? 10 divided by 2 is 5. Is there an interaction? 20 divided by 2 is 10. All right, so I've kind of worked through my knowledge of how do I calculate F? How do I calculate my variance or my mean squares? And then basing off information of how many groups are in my conditions, how do I solve and work through this table? I would like you to pause, and I would like you to go through and solve for this given the information here in this table. So this table has a bunch of places for you to solve. There's 9 different places for you to solve. X1, X2, X3, X4, X5, X6, X7, X8, X9. I've given you general information. There's 3 levels for game, and there's 2 levels for gender. Again, 2 minus 1 is 1. That answer is already there. The key, so then you're just going to identify which ones do you think are significant based on knowledge of things greater than 1 are typically significant, things around 1 or less are not. The key is at the end slides. So you're going to have to go to and download the PDFs. Oh, wait. So again, encourage you to figure that out. You're going to have something similar for your homework. So again, understanding interactions. Interactions is once more the thing that we're going to place the most weight on, the thing we're going to interpret. If I have significant main effects with interactions, I'm cautious about interpreting my main effects. So let's go through and see, how do we identify interactions when we are looking at our data very superficially? So that's what we're going to be doing now. So here's a review. Here are our cell blocks, marginal means, marginal means. This same data is graphed here. All right, so if I see number differences here, I would assume a main effect. If they are similar, I would assume there's no main effect. If there's any crossover, there would be an interaction. So in this case, I do have a main effect for profession with actors and comedians. I do not have a main effect for country. I do not have an interaction. Here, looking at my cell blocks, again, my cell blocks are displayed here on my graph. I have a main effect for country. I have a main effect for profession. These numbers are different. Again, marginal means is 3 plus 7 is 10 divided by 2 is 5. 1 plus 5 is 6 divided by 2 is 3. So that's how you got those marginal means. Main effects, ignore the other condition, are just focused on the levels for your one factor. And then your interaction is none. So you have that key right there as well. Let's look at these. Do we have interactions in these? Just by looking at the graphs, you should say, I think we might. So we've got crossover here, we've got crossover here. Again, that shows there's interactions. There's interactions. In this case, we have no main effects. In this case, we do have one main effect and no main effect for nation. So what I'd like you to do is get out your PDF handout, and that's going to show you all these different ways. These are the 8 possibilities you can have with a 2x2 factorial design. And I am also going to pull up that PDF and kind of go through it with you. So you do have these as a handout for they also are embedded in the PowerPoint slides. The other thing I do want to note is whenever you have any design that has only 2 levels of the factor, ask yourself, do you need a posthoc for those? I'm going to tell you no, you don't, because you only have 2 groups. So if you find there's a main effect, you would know that they're significantly different from each other. If I had a 3x3 design though, like we did with the NPR study, I would need a posthoc, right? So I'm not going to focus on posthocs with the Factorial ANOVA. I want you to get, we've got this new F, this interaction, and kind of work through that and get that. But do know if you had a more complex design that was a 2x3 or a 3x3, again, more than 2 levels of your factor, you've got to do a posthoc. Okay, so let's switch gears and kind of quickly go through these 8 different guys, these 8 different scenarios. All right, so here is that handout. So you've got these 8 different scenarios. Again, all we're going through and doing is connecting. Do we see a main effects? Do we see interactions? So I'm going to look here. Do I have a main effect? No. Do I have a main effect for A? No. Do I have an interaction? No. These are as if there's 2 conditions here and 2 conditions here, and it's all the same data. All right, so there's nothing going on there. It's also indicated I got a kind of a key there, but don't cheat. Try to look through each one. Let's go through this guy. Do I have a main effect for A? I'm going to say yes. Those 2 numbers are different. Do I have a main effect for B? No, those are the same. Do I have an interaction? Here, we do not. Again, it's just showing a line, 2 lines. Those are 2 lines on top of each other. They're parallel, so there's not an interaction there. All right, and again, that's my key to kind of go through things with us. Next scenario, do I have a main effect for B? Yes. Do I have a main effect for A? No, those numbers are the same. Do I have an interaction? No, I do not. Again, if I were to go through this, I'd see a graph like this with my bars. And again, 2 parallel lines. No interaction. I have, so I just have that main effect of B. Okay. Next, again, you should be connecting the dots as your own. Do I have a main effect for B? No. Do I have a main effect for A? No. Now we're going to look inside our cell means. Do I have an interaction? Ah, yes, I do. I've got that crossover. All right, so that's indicating there is an interaction. And this is kind of our classic interaction that was the same as that Aaron study with task difficulty and sensitivity. They didn't have any main effects, but they had an interaction. That's the same sort of example. All right, so then let's go and connect some more. Do I have a main effect for B? No. Do I have a main effect for A? Yes, I do. Do I have an interaction? Yes, I do see that crossover, right? And again, these would be as if there are 4 bars here. You're seeing those four bars are crossing over. So all I'm doing is connecting the bars, and that's what's making those lines. So yay, so we've got the A in the interaction. Let's check out another one. Do we have a main effect for A? No. Do we have a main effect for B? Yes. Do we have an interaction? Yes, we do. Although it's not this perfect crossover, you are seeing this touching. And so this touching right here is an indicative there is that interaction. Okay, so then we're going to try one more. Do I have a main effect for B? Yes. Do I have a main effect for A? Yes. Do I have an interaction? No, I do not. I don't. I just see 2 parallel lines, no touching, no crossing over. Do I have a main effect for B? Yes. Do I have a main effect for A? Yes. Again, this is very superficial. We're just looking at these differences in real life. You look at your F for B, you look at your F for A, and you look at your F for interaction. Again, we do have that interaction because we've got those lines intersecting right there on there. So in this case, you've got everything going on in that scenario. Everything's significant. Again, when everything is significant, it is the interaction that I am going to spend my time interpreting, because that's really carrying the uniqueness of what's going on with this. So it seems to be for people who are in this condition right here, right, this condition right here, they are responding differently to that treatment or to that intervention, etc. So I do encourage you to kind of go through again, see the handout. Can you identify these different possibilities for a 2x2 design? And so again, this is going to connect to just your understanding again of the different ways we can see our output when we have those 3 F's. Right, so this is conclusion for part 2 of your Factorial ANOVA video, and I hope you're having a great week. Thank you for watching.